So far in our discussion of rational numbers, we've been considering fractions. This makes sense because the definition of a rational number is the fraction whose numerator and denominator are both integers. However, this isn't the only way to represent a rational number, and sometimes it's more convenient to use other forms, such as decimals or percents. That's what we're going to look at today, as we see how we convert from one form to another. Firstly, we'll look at decimals and percents. Percent literally means to divide by 100, or parts out of 100. So 100% is equal to 100 divided by 100, which is 1. In general, this means we can convert from percent to decimal by dividing by 100, and we can convert from a decimal to a percent by multiplying by 100. So as some examples, 40% is the same as 40 divided by 100, which is 0.4. 83.1% is the same as 83.1 divided by 100, or 0.831. And 275% is equal to 275 divided by 100, which is 2.75. Notice in that last example, our percentage was over 100%. That means that our decimal is over 1. That's a good benchmark to use to make sure our answers make sense. Let's look at some examples that go the other way, from decimals to percentages. 0.7 is the same as 0.7 times 100%, which is 70%. 0.042 is the same as 0.042 times 100%, which is 4.2%. And 4.2 is the same as 4.2 times 100, which is 420%. Converting fractions to decimals. In an earlier lesson, we saw that every integer, every terminating decimal, and every repeating decimal is a rational number. Well, it turns out every rational number is one of these three: an integer, a terminating decimal, or a repeating decimal. As an aside, this does not include every single type of number. There are numbers that don't terminate, so their digits keep going on without end, but they don't have a repeating pattern. But we'll look at those in a future lesson. Now, because mathematically fractions and divisions are the same thing, we can treat a fraction as division to convert it to a decimal. If we want to write a fraction in decimal form, one way to do it is to make sure that our denominator is 10 or 100 or 1000, so we have a simple way to interpret it as a decimal. So 3/5, for example, is the same as 6/10, which is 0.6. 11/25, multiplying both the numerator and denominator by 4, we get 44/100, which is 0.44. For the mixed number 4 3/4, we have an integer part, 4, and a fraction part, 3/4. We can write this as 4 75/100, which will be 4.75. Notice that a decimal point separates our integer part from our fractional part, just like we have with the mixed number. Now, often, it's more practical just to use a calculator to do our divisions. So, 97/80 is the same as 97 divided by 80, which is 1.2125. 8/11, same as 8 divided by 11, which is 0.72727272. Now, your calculator will eventually terminate here, but we can see that there's a pattern which repeats. This is actually 0.72 with the 72 repeating. Now, be careful with what your calculator tells you. It might round the final digit at the end, so the very end of what your calculator displays won't be exactly the same as the repeating pattern, but that's really what it is that's going on. 49/15 is the same as 49 divided by 15, which is 3.266666 going on without end, which we can write as 3.26 repeating with only the 6 repeating. Converting decimals to fractions. Now remember that each place value after the decimal point represents dividing by a larger power of 10. So 0.1 is 1/10, 0.01 is 1/100th, 0.001 is 1/1000th, and 0.0001 is 1/10,000th. And this pattern goes on in the same way. Now using this, we can write any terminating decimal as a fraction. The number of digits after the decimal point tells us how many zeros the denominator should have. So if we have 0.65, this is the same as 65 100ths. We can simplify this fraction because both 65 and 100 have a common factor of 5, so that is 13 20ths. 3.4 is the same as 3 and 4 tenths, which is the same as 3 and 2 fifths. 0.425 is the same as 425 1,000ths, which simplifies to 17 40ths. And 1.012 is the same as 1 and 12 1,000ths, which simplifies to 1 and 3 250ths. Now, repeating decimals are a little more difficult to convert, but we can use a property that 0.9 repeating, which is just 0.99999 continuing on with nines without end, this number is actually equal to 1. For now, I'm giving you this fact without proof, but this probably should be something that you investigate more in the future. So 0.1 repeating is the same as 0.1 repeating over 1. Though instead of writing 1, we're going to write 0.9 repeating. Both this numerator and denominator can be divided by 0.1 repeating, which leaves us with 1/9. If we have 0.01 repeating, we can use the same idea, except our denominator is going to be 0.99 repeating. Again, that denominator is equal to 1. Dividing both of these numbers by 0.01 repeating, we get 1/99. Taking this idea even further, we can do 0.001 repeating by putting that over 0.999 repeating, and we can simplify that to 1/999. Let's use these results to write some repeating decimals as fractions. For 0.6 repeating, we have one repeating digit, so we can write it with a denominator of 9. 6/9 simplifies to 2/3. 0.45 repeating has two repeating digits, so we can write our repeating digits over 99. This simplifies to 5/11. 0.259 repeating has three repeating digits, so we can write this with a denominator of 999. This fraction simplifies to 7/27. Now, it's a little more difficult when we have a mixture of non-repeating and repeating digits after the decimal point. But let's look at how we can do this. The first thing I want to do with 0.73 repeating, where only the 3 is repeating, is shift it so only the repeating digits come after the decimal point. So really, I want 7.3 repeating. Now, this isn't really the same number anymore. However, I can make it so that it is the same number by multiplying it by 1/10. That's just the same as dividing by 10, but it's more convenient to write it this way. Now, the 7, that's an integer part, we can just write it as 7. 0.3 repeating is one repeating digit, so we can write it over 9, so 3/9. That 3/9 simplifies to 1/3, so our mixed number, 7 and 1/3, can be written as 22/3. Now this 1/10 that's been hanging around the whole time, we can incorporate that by multiplying and we get 22/30. For 0.118 repeating, where only the 8 is repeating, we want to shift this over so we have 11.8 repeating. So only the repeating digits come after the decimal point. We can make sure this has the same value by multiplying it by 1/100th. Now, 8 repeating is the same as 8/9. So we have 11 and 8/9, which is the same as 107/9. Multiplying this by 1 over 100, we get 107/900. And finally, 0.128, where the 2 and the 8 are repeating. Well, let's shift it over like we have before, where we have our non-repeating digits before the decimal place, and our two repeating digits, the 2 and the 8, after the decimal place. To keep this with the same value, we need to multiply by 1/10. Well, this is the same as 1/10 times 1 and 28/99. So just changing our repeating digits into a fraction over 99. 1 and 28/99 is the same as 127/99. We're multiplying that by 1/10, so that is 127/990.